Let's talk about operations on matrices. Before we go deep into the operations, in my last video I talked about addition and subtraction. Today I want to talk about multiplication of two matrices. Now, before we go deep into the details, I just want to clarify something about order of a matrix. Now, order of a matrix is determined through the number of rows by the number of columns. For example, xy is a 2, xy is a 2 by 1 matrix. Yes, because the number of rows here are 1, 2. 2 rows and columns is only 1. That is why we call this kind of matrix here a 2 by 1 matrix. Now, let's look at another one here. This is x, y, z. Now, this one here is a 3 by 1 matrix. Why? Because the number of rows are 1, 2, 3. 3 rows here, and there is only 1 column. Let's take another one here. M, N, O, P, Q, R. Now, this one is a 3 by 2 matrix. Why? Because the number of rows are 1, 2, 3, and columns are 1 and 2. Yeah, so all this is called the order of a matrix. The order of a matrix. And now, talking about multiplication, you first of all need to ask yourself if you want to multiply a matrix by another matrix. Is it possible? Now, for two matrices to be multiplied, or operating multiplication on two matrices, for it to be possible, the number of columns in the first matrix must be equal to the number of rows in the second matrix. You need to take note of that. For example, a 2 by 2 multiplied by 2 by 1 is possible because the number of columns in the first matrix is 2. So the first matrix, the number of columns is 2, and the number of rows in the second matrix is also 2. So the two are equal, and if that is so, then operating or multiplying the two matrices becomes possible, and the result will be a 2 by 1 matrix. A 2 by 1 matrix. This one by that matrix. So this one is the row and this one is the column. All together. So row by column. Okay. What does that mean? It means that given matrix A, or I want to use another word. Given that multiplying two matrices, one matrix is a M by N matrix. This one is to be multiplied by a P by Q matrix. Now, this operation is only possible if N equals P. That is, the number of rows, the number of columns in the first matrix equals the number of rows in the second matrix. Yeah. Now, so that multiplication is possible. Now, the result will be a M by Q matrix. A M by Q matrix, considering that the number of columns in the first matrix equals the number of rows in the second matrix. Now, that one is now able to give us a leeway on how to proceed by looking at how do we multiply matrix. Now, just to summarize, I'll just say that the order of a matrix is determined by the number of rows by the number of columns. Number of rows by the number of columns. I've also said that two matrices can only be multiplied when the number of columns in the first matrix equals the number of rows in the second matrix, and the result will be just as I've shown here, that M by N times P by Q. The result is M by Q. This given that these two are equal, the columns here equals the number of rows there. Okay, let's proceed and look at how do you multiply two matrices. And in this case here, I'm going to focus on a 2 by 2 matrix. Okay, this is how you proceed. So I'm going to look at given matrix A. Given matrix A equals M N O P, and matrix B equals A, B, C, and D. Given the two matrices, now work out A, B, or work out A times B. Now, this is how we proceed. So you take A, that is Mn or P, and then multiply that by A, B, C, D. Now, this is how we proceed. So this one is equals to B. Okay, we are going to proceed as follows. Now, we are going to multiply the elements. We are going to look first of all the first matrix. Take the elements of the first row, for that R1, multiply by the elements of the first column, that is for the second matrix. So the first matrix, take the elements of the first row multiplied by the elements of the first column in the second matrix, and the result there is going to be we shall multiply and then add. So this is how we proceed. So take M times A, that is MA, and then you add to N times C, that is NC, that is NC. Again, multiply the elements of the second row by the elements, and then add to the product by the elements of the first column. So we come to row number 2 by first column, yeah, and that becomes O times A, that is OA, and then add P times C, that is PC. All right, let's come now to the first row and the second column. First row and the second column, that is the second column of the second matrix. Now we shall have M times b, that is m b, and then add n times d, that is n times d. Lastly, we come to the second row. The second row, we multiply the elements by the second column. All right, so you take O times B, that is OP, and then add P times D, that is PD. So this is how we multiply a 2 by 2 matrix. That is how we multiply a 2 by 2 matrix. As simple as that. Now, how about you can also multiply a 2 by 2 matrix. So given another matrix C equals x, y, how do we get or you can evaluate AC. Evaluate AC. So you pick matrix A, that is M, N, O, P, and then multiply by x, y. Now from here you can predict the outcome, because this is a 2 by 2 matrix multiplied by a 2 by 1 matrix. So the result should give us a result of a 2 by 1 matrix. Let's see if that is true. Now we proceed. This is how we proceed. So this matrix, second matrix, has only one column, and this one has 2 columns and 2 rows. So the procedure still remains. So we take the first row, multiply by the elements in the second matrix, and we shall have m times x, that is mx. We add n times y, that is ny. Right? That is the first row. So that is the first row, first column. We come to second row, first column. We shall have now O times x, that is 4x. You add p times y, that is py. Now that becomes our answer. That becomes our final answer, which is mx plus ny and 4x plus py. So you find that this is the result is a 2 by 1 matrix, because there is only one column in that matrix. You can also have another example here, whereby you have another matrix, given another matrix D is given as we have let's use other values, like let's say for example ABCD. Okay, E, F, G, H, I, J. Now this is a 3 by 2 matrix, and you can also be asked to multiply and okay, we can get another matrix let's take another matrix E. It's given as you can take an example of maybe a 2 by 1 matrix. You can call that one 4, 3. So that is a 2 by 1 matrix. So DE, you can be asked to evaluate DE. That is D times E, whereby D is a 3. This is a 3 by 2 matrix. You multiply by a 2 by 1 matrix. Now from here you can predict the outcome. We said the outcome is this number of rows by that number of columns, which is a 3 by 1 matrix. Can we now solve and find out if it is true? let's proceed. So DE, so let's proceed. So you just take E, F, G, H, I, J. Multiply that one by 4, 3. Now multiply the two and get the values. So we shall have E times 4. That is, we start with the first row, first column. So that is E times 4, which is 4E plus H times 3, which is 3H. Now second row, first column, that is F times 4, that is 4F. You add to I times 3, which is 3I. Now row 3, column 1 will be now G times 4, that is 4G plus J times 3, that is 3J. And that becomes our final answer, which is 4E plus 3H, 4F plus 3I, and finally 4G plus 3J. Now, that is how we go about multiplying two matrices, and you can see here this result here is 3 by 1 column, 1 matrix, I mean, because number of rows are 3 and 1 column, as simple as that. Now up to there, I hope you now understand what is the order of a matrix, when two matrices can be multiplied, and you can be able to predict the order of the result and so forth. So make sure you subscribe to my YouTube channel so you won't miss on my next content. Share with your friends. Otherwise, thank you for now.